I'm a professional mathematician and I'm going to help you master graph transformations and graphing with the absolute value in a step-by-step way. This tutorial is based on my lectures at Princeton University, where I've received a university-wide faculty teaching award, and I'm going to show you the step-by-step guide to mastering how to graph these kinds of functions. We're going to start off in small baby steps, so it's going to be very clear for you. So let's start off with the first function, and what I'm going to do is I'm going to start off with the fundamental concept of the absolute value function itself. So the absolute value function is the function y equals to absolute value x. Okay, and we know the graph of this function, so that's right from the beginning. What is the graph of that function going to be? It's going to be this V shape here. Okay, so you're going to have a V here, and essentially what's going on is this is the function that is equal to x when x is greater than 0. So absolute value of x is the distance from x to the origin in the number line. Okay, so if x is positive, the distance from x to 0 is just x. If x is negative, the distance from x to 0 has to be negative x, so that it's a non-negative number. Distances are always non-negative, so the absolute value of -3 is minus of -3, which is +3. And here you have the line y equals x on this right hand side, and you have the line y equals -x on this side. Okay, so that's how the graph of y equals absolute value x is. Now what about the graph of y equals absolute value x minus 3? Okay, we're going to do this in some baby steps. Now what I want you to think about is the difference between these two functions, and we'll make this precise shortly. But the difference is that the x coordinate is just changed by 3, right? So everything here and everything here, the x coordinate just differs by 3, and that tells you the graph of y equals absolute value x minus 3 is a horizontal shift of the graph of y equals absolute value x. But how are we going to shift it horizontally? Are we going to shift it to the left or to the right? And this is where things get a little subtle and can be a bit confusing, but I'm going to make it very simple. So what we want to do is we want to think about what it means to be a point on the right hand graph. Okay, so if xy is a point on this graph, x comma y, is a point on this graph y equals absolute value x minus 3, that just means that y is equal to absolute value x minus 3, right? That's just what it means to be a point on the graph. But what that means is that if xy is a point on that graph, that's the same as saying that x minus 3 comma y is a point on the graph y equals absolute value x, right? Because to say xy is a point on this graph is to say y equals absolute value x minus 3, and that just means that x minus 3 comma y is a point on this graph. You plug in x minus 3 there, you get y equals absolute value x minus 3. That means that this graph shifted 3 units to the left because x is getting replaced by x minus 3 will give us this graph. Okay, so just to say, to go from the right graph to the left graph, we want to shift 3 units to the left. And what that does is, by saying we're shifting 3 units left, to go the other way, we want to shift 3 units right. Okay, so I'm going to write it here, shift 3 units right. Okay, so that's what we are doing to go from one graph to the other. We're going to shift 3 units right. So in other words, we've got this graph here. We know that this is the origin 0, 0. We just want to shift everything 3 units to the right, and I'm just going to do that with a red marker here. So we're going to have 3 here. Okay, so instead of 0, 0, we're going to have 3, 0. So I can even write, instead of an x coordinate, I'll just write the point 3, 0. And now we're just going to have the graph that's going to go like this. So it's going to just do this, and you're going to get this graph here. Okay, so I can't draw it across the board, but you get it's a V shape. Okay, and what's important is sometimes you want to denote the y-intercept and the x-intercept whenever you have a graph. So for the y-intercept, you want to plug in x equals 0. That's when you're on the y-axis. Okay, so all axis labeling is also good practice. So I'm going to label this here. This is the y-axis. So sometimes people take off points. So now you just want to plug in x equals 0, and you get x equals 0, you get y equals absolute value -3, which is just +3. Okay, distance from -3 to 0 is just going to be 3. That's what the absolute value represents. So here we could say this point is going to be 0, 3. Okay, and again, I could have just denoted this by 3 and 3. That would have also been fine. I'm just denoting the x and y coordinates simultaneously. So we see that absolute value x minus 3 is 3 units to the right, even though it's a negative sign. So it's a little counterintuitive, but we'll get the hang of it. Okay, so now that we've gotten this far, the next step is, what do we do with the 2 times and what do we do with the +5 times? Okay, so I'm just going to now just nicely keep everything neat on the board and show you that. Alright, so if you're enjoying my content so far, please don't forget to smash that like button and subscribe. Makes a huge difference so I can help as many people as possible and help power you through your math journey. And subscribing keeps you constantly notified because I do math at all levels and I love helping people. So here we've got the graph of y equals absolute value x minus 3, and I've just denoted the 3 on the x-axis and the y-axis for the x and y-intercepts. And now again, I'm just going to label this with the x-axis and the y-axis. What happens when we take 2 times the absolute value of x minus 3? What's going on there? So the way I like to think about it, and it's pretty simple here, it's more intuitive. 2 times absolute value x minus 3 means all y values are multiplied by 2. Okay, so the graph is going to become steeper because the y values are going to get multiplied by 2. So instead of here you have an x value, here you have a y value, instead you're going to have twice the y value. Okay, so we can just draw this in a nice way. I'm just going to do it in red. So you can sort of draw it like this. Okay, so this is going to be my drawing. So you've got the graph. It's going to be twice as steep. Okay, so that's roughly what it's going to look like. And we're going to find out the y-intercept. The x-intercept is going to be similar. Okay, so here I'm just going to write out y equals to 2 times the absolute value of x minus 3. The x-intercept is when y is equal to 0. It's just nicely on that x-axis, and that's when x is equal to 3, just like before. Okay, so there's nothing changed there, which makes sense. But what happens to the y-intercept is that's when x is 0. Okay, so if you plug in x equals to 0, you're going to get y is going to equal to 2 times the absolute value of negative 3, which is of course 2 times 3. Absolute value of negative 3, distance from negative 3 to 0 on the number line. So that's just going to equal to 6. So here we're just going to have 6 for our y-intercept. And you see that you've got this steeper version. Okay, that's going to be y equals 2 absolute value x minus 3. And finally, we just want to do the last step, and this is what we call graph transformations. We're doing step by step. Okay, so you just start off with whatever is changing with the x, and then you do the first step, which is multiplying by 2, and then you do the adding 5. And the last 2 steps are pretty nice. Okay, so let's just finalize it here. All right, so now how do we do the last one? So what we're interested in, so I'm just going to try to draw this here. Okay, so just trying to draw everything, fit it on the whiteboard neatly. So it's going to be a little tricky. I'm just going to change the scales a little bit, okay, make it a little finer. Because what's going to happen when we add that 5, okay, so it's going to be pretty intuitive. So I'm just going to do again, we're going to put the intercept here. So it's going to be 3, it's going to be 3, there's going to be 6, and I'm just actually going to do 11 here. Okay, so we'll see why we're doing 11. Now, what's going to happen is when we add the 5, when we take y equals to 2 times the absolute value of x minus 3 plus 5, all the y values are going to go up by 5 units. The x values are the same, right? So if you take an x value, its y value for the top graph was whatever it is, 2 times absolute value x minus 3. Its y value from the bottom graph is 2 times absolute value x minus 3 plus 5. That means all the y values have gone up by 5. That means the graph is vertically shifted 5 units up. Okay, it's not counterintuitive like the absolute value x minus 3 was minus 3, but it's shifted 3 to the right. Here it's actually plus 5, it's shifted 5 up. Okay, the signs are consistent with what you'd expect maybe. And so now what we do is we just put, so I'm just going to put a little 5 here. So this is 6, this is 5. Okay, so I've just labeled it on the axis. And what's going to happen is now our graph is going to start at the point 3, 5. Okay, that's where our graph is going to start at. Our y-intercept, instead of being at 6, is going to be at 6 plus 5, which is 11. So we're going to have the graph that's going to go something like this, and it's going to go something like this. So that's going to be our graph of y equals 2 absolute value x minus 3 plus 5. Pretty nice, okay? So the key point when you're graphing this is you just want to label that 3, 5 and label the relevant points on the axis. We didn't actually need to label the 6, okay? So if I wanted to be very, very neat there, I would just kind of do that, erase this, and just put a 5 here, okay? I just wanted to do that, so there we go. So we've got 3, 5. Now I want to help you practice and master this absolute value problem. Okay, so it's going to be a little bit different, but it's going to reinforce the concepts. I want you to think about it and just follow along with me. So let's get to that right now. And also, if you're loving my content so far and you want to support my channel a bit more, please consider checking out the Patreon link on my description. Small contributions there make a world of difference. I do everything on my own and I love helping people. So if I'm helping power you through your math education, check out that Patreon link. And a huge thank you so much to Alex, Nathan, and Trang for their ongoing support on Patreon. On Patreon, there's an exclusive access to a Discord server, members only. There's exclusive news and updates about my channel, personal personalized thank you message, and priority reply to your YouTube comments on my channel. I value every supporter very much, and it makes a big difference to my channel. So let's now get to graphing minus 3 absolute value x plus 1 minus 2. So you're going to go through the steps again pretty carefully, but here we're just going to think about it in the first step was we have y equals absolute value x and y equals absolute value x plus 1, and we want to understand how these two graphs shift. Now I'm going to give you a quick shorthand as well. Okay, so a quick shorthand to figure out whether it's to the right or to the left is just figure out when y is equal to 0. Okay, so with y equals absolute value x, we know that y is equal to 0 at the origin when x is 0. And when y equals absolute value x plus 1, you just know that when x is negative 1, i.e. when x plus 1 is 0, that's when you're going to have a y value of 0. So you're going to be shifting now to the left, which is the opposite of the previous case when you had an x minus 3. Now we have an x plus 1. So we're going to shift to the left. So here we have a minus 1. And we're going to notice that our y-intercept is again going to be when x is 0, right? So x is 0 is when we have the absolute value of 0 plus 1, which is just the absolute value of 1. So we're just going to have this nice graph, which is shifted 1 unit to the right. Okay, so that's very convenient. And also you can think of it in the previous way that if x, y is a point on this graph, right? If y is absolute value x plus 1, that implies that, if we go here, that implies that x plus 1 comma y is going to be a point on this graph. Because we know that since y is the absolute value of x plus 1, that means that y is the absolute value of x plus 1, so it's going to be a point on this graph. Y is the absolute value of the x input, and so therefore, you're going to shift, this is a shift 1 unit to the right. And so therefore, you can see that to go in the other direction, to go from this one to this one, you want to be shifting 1 unit left. Okay, so that just gives you that rigorous feel for what's going on. And now we're just going to do the next bit, which is a bit interesting. You've got the negative 3 absolute value x plus 1. How's that going to work? So let's just think about that right now. All right, so now we've got the graph of y equals to the absolute value of x plus 1, and we want to figure out what is the graph of y equals negative 3 absolute value x plus 1. Now the first thing to keep in mind is when you have a negative sign, all your y values are going to, so forget the negative 2, right? Okay, so first of all, we're just looking at y equals to negative 3 times the absolute value of x plus 1. And I'm going to do this in one step, but the first step is the negative sign. If you don't have the 3, just have a negative sign, all the y values are going to become negative. So what you're going to instead have is you're instead going to have the graph, and let's just delete this here. You're instead going to have the graph that looks like this. Literally the reflection of this graph in the x-axis. Okay, so this is going to be a y-intercept of negative 1. Okay, you don't even have to think about it. You don't even have to do the algebra. You could. X is 0, absolute value 1, negative of that is negative 1. But you can visualize it geometrically, and then you want to multiply by 3. Okay, so then if you're looking at, okay, I want to find out y equals negative 3 times the absolute value of x plus 1, well then I'm going to multiply everything by 3, so I'm going to make it 3 times as steep, right? All the y values are now going to be multiplied by 3, so instead of going like this, they're going to go like this. And you can then see sort of that minus 1 you're going to have in negative 3. Okay, you're going to have a negative 3 here, and so you're going to have something like this. It's going to be 3 times as steep. Okay, I don't know if I drew this perfectly, but that's roughly what's going to happen. Okay, it's going to become steeper, and you're going to get that graph. Okay, so this is going to be y equals negative 3 times the absolute value of x plus 1. Now the next and final step is what happens when you subtract the 2. Okay, so for subtracting the 2, it's what you'd expect. All the y values are going to drop by 2 units. Right? That's all it means. When you subtract the 2, all the y values are going to drop by 2 units. So it is a vertical translation 2 units down. So because of that, what's going to happen is instead of your vertex here going to be at minus 1 comma 0, right? Instead, your vertex is going to be at minus 1 comma negative 2, right? So your y coordinate is going to become negative 2 instead of 0 for your vertex. So you're going to have a point here, so I'm just going to put this as negative 2. It's going to be here, and your graph is going to be, your line is going to be parallel to this one, okay? And it's just going to go down like this, and instead of cutting at negative 3, you're going to cut at negative 5, okay? You're going to go 2 units down. So you're going to cut at negative 5, and now you can just draw that nicely. You can draw this graph. It's going to go like this, and you're going to have this graph, okay? And this is going to be the graph of y equals to negative 3 absolute value x plus 1, negative 2, and your vertex is going to be at the point. What's the point going to be? The point is going to be negative 1, negative 2. And there you have it. Okay, that's how you graph that function. And I've just shown you the step-by-step process, so I want you to sort of play around, okay? It's really important practice. Just change the numbers up, okay? Make it something like, negative half, for example. Let's make it interesting. Negative half times the absolute value of x minus 7 plus 3. Try that out, check that out. Now, I want to help you master the absolute value, and I've got content on my channel for you. So here's 2 videos you're going to love, okay? The first video is going to be how to solve equations with the absolute value. Nice compliment to this one to really ingrain it. Check out that video here. And another fun video you're going to love if you're interested in more graphing, how to graph the equation of any circle from scratch. Pre-calculus content's very fundamental. Gonna love that video. These are just quick videos, 15 minutes. You're mastering core concepts that are used throughout pre-calculus and calculus. So check out those videos, and I'm super wishing you the best, all the best, and super excited to see you in the next video.